Hello, everybody. I'm very happy to be here today. I didn't expect so much interest in multitenancy. I hope you will enjoy the talk. So let me first introduce myself. I have a lot of experience developing web applications. I work in a company called Faber. We are based in Bilbao, in the north of Spain. We do not have like a big product that we are developing, but we develop special solutions for our clients, like small web applications that solve special problems. We started back in more than 20 years ago, so started to using OpenACS like a framework, which is already forgotten, I think. And so we go all the way through different options for the web development. We were early adopters of the Ruby on Rails framework. We have been developing applications with it for a long time, and since like 5 years, more or less, we have started using Phoenix for some of our projects. So I have a lot of experience developing web applications, not so much experience with Elixir. And one of the projects that we have been developing recently was about the multitenancy. And I thought that it can be interesting to know about this approach. It's not useful for any cases, but it can be very, very useful and make the development easier if you know when to use it. So I have split the talk in 3 parts. First, I will talk a little bit about what multitenancy is, the special implementation that we will use during the talk. Then I will show you how it fits into the Phoenix request lifecycle. And finally, I will show you how it can be implemented using a special library I have been using for this, which is called Triplex. Although you can implement the same functionality by yourself or using another library. So let's start with the definition. The multitenancy is a software architecture where one instance serves different clients. In order to make the distinction between the final client of our application and the client that asked for the application, or the one that owns the data and manages it, we will talk about different tenants. So the tenant is the one that owns the data. Okay, what we will be talking about is about application where we have different tenants, but we use one instance of the application to serve them all. Like the physical architecture limits what a building can be and how it can be used, the software architecture limits what the software can be and how flexible it is to be extended or to be changed. So it's very important to choose the software architecture that fits the problem that you have to solve. It can make your work easier or not. So we have to think about it before we start with our implementation. For the case that I will be talking about is the case where we have one application that will serve all the tenants. Each tenant will be identified by the URL. You can identify it by the subdomain, for example, of the host, or you can have the same host and use a URL parameter to identify the tenant you want to access. And also, very important, the data for all of the tenants is independent. Each tenant has its data encapsulated. So when we ask for data, we always know which tenant we have to access, and we will never mix data from different tenants by definition. Before I start with the details of the implementation, let me just spend a few minutes trying to explain with a comparison with Bakery where multitenancy fits in all the process. Imagine that what we know how to do are cakes. We have our tools, we know how to prepare the mixture, we know how to cook it, we have a lot of different cake pans. So just with little changes in the mixture or in the shape of the cake pan, we can prepare a lot of different cakes. And it, in general, can be enough. But sometimes there are special occasions when the cake is not, it's not a good fit. So if for some reason we have to prepare waffles, all the tools that we have and our knowledge is not enough to prepare a good waffle. We have to augment it a little bit and adding some more tools in order to have the result that we want, and we have to learn how to prepare the mixture in order to have a good result. So in this case, we have to add another tool to our tool set, which is a waffle maker. So the multi-tenancy is more or less like this waffle maker. You don't have to use it always. But if your problem fits into the requirements that multi-tenancy fits, it can be very easy to develop your product, and it's very flexible to extend it further. So when to use it? The most important thing that you have to take into account that you have to have independent tenants. So all of the clients, the data of each client, it's always independent from the rest. You don't want to mix the data from one with the another. And also, all of the tenants have the same structure of the data. Although the content is different, the structure has to be the same in order to provide the access to this data through the same application. Also, it can be very useful if you have limited resources, because we only need one instance of our application to serve all of the tenants. Don't have to start a new application for each new tenant. So let's see how it can be done with Phoenix. First, I will make a very short review of the Phoenix lifecycle, just to put it all in context. I suppose all of you already know this, but I would like to start with this to show you which points of this lifecycle we have to change in order to have a multi-tenant application. So when a request comes to the Phoenix application, it goes to the endpoint where there are a set of plugs that will assign different values to our connection struct. Then this information goes to the router where we can add some more plugs and scope the requests. And then we go to the controller where the requested information is obtained and formatted and passed to the view, which is responsible for responding with the appropriate format. In order to obtain the requested information, the controller speaks to our business domain, where we have defined our context, which then use Ecto library to connect to the database. So this is how the Phoenix lifecycle works. If we want to have this application multi-tenant, we have to make some small changes. Okay. So the first thing that we have to know is which tenant we want to work with. So we have to add another plug, which will take the tenant from the request data and save it in a sign that we can use further from the controller. When the controller speaks to our business domain, it has to pass the tenant that we have assigned as a parameter in order for the Ecto library to know which database to connect to take the data. Fortunately, Ecto library is already prepared for this. All the functions that this library defines have a parameter called prefix that you can use to identify which of the tenants you want to use. Depending on the database that you are using, in each case, it is handled differently. If the database is PostgreSQL, the PostgreSQL already has implemented the concept of schema, which has nothing to do with the Ecto schema, just a name. In Postgres, you can have different schemas, which are totally independent from one another, but they are saved in the same database. So if you pass a prefix like argument to the calls to the Ecto functions, Ecto already knows that depending on the prefix, it should take the data from one tenant, from one Postgres schema or another. If you use another database, like MySQL, for example, you have to have different databases for each one of the tenants. But this is something that Ecto already takes into account. So in fact, in your code, you don't have to do anything special depending on the database that you are using. So in summary, there are 3 steps that we have to change. We have to add to the Phoenix life cycle in order to prepare it for multi-tenancy. The first one is create the tenants. This is something that we can do outside of our application, creating the databases or the tenants that the Postgres schemas that we need, but we can use also a library for this work. Then we have to add a plug to assign the current tenant somewhere in the endpoint or in the router in order to have this information in the rest of the process. And finally, we have to pass this parameter through the calls to the database and get the relevant data depending on the tenant that we have chosen. So let's see how this can be implemented using the triplex library. This is the definition of the triplex library. This is the one that I have used in the project that we have developed. I think there is another one too, but I have no experience with them. So the triplex library already provides us with all of the functions that are necessary for creating, renaming, or dropping tenants. You always give the tenant a name, and then triplex takes care for creating the corresponding schema or database, depending on the database that you are using at the backend. You can rename the tenants, and you can drop them if you don't need them anymore. For the next step, which is assign the current tenant using the URL, triplex also provides some predefined plugs depending on where the tenant is in the request. You can, depending on your case, you can use param plug, session plug, or subdomain plug. I will show you some example for the case of the param plug because I think it's like the easiest one. For example, if we will identify our tenant with a parameter of the URL, what we can do is define a special pipe in the router EX, which will use the triplex param plug and assign the current tenant to the parameter called tenant, which you can define here when you are calling the plug. Then you can create your scope for each tenant that defines that the tenant will be the first parameter and pipe all of the requests of this scope through our new pipe. And then we define the routes. We can have live routes or the normal routes. Then in your code, if in your controller you already have access to the tenant parameter, like assigned in the connection struct, you can take it from there and then make the calls to your context functions in order to get the data for this tenant. Also, you have access to the tenant in your views. If you are using live view, as we have defined the tenant as URL parameter, you already have this information like value for the params attribute of the mount function. So you can take it, assign it to a socket if necessary, use it when calling your context functions. And if you know that you will always have assigned a tenant, you can also define on mount hook, so it will be assigned for all of the live views you are using. And finally, we have to consider the case when the tenant that the user provides as part of the URL does not exist, but triplex already have a special plug for this case where you can define the callbacks in case of the tenant is not found in your database. And finally, we have to get the data from the database for the tenant that we have already get from the request. For this, Ecto already has all that we need. You just have to add the prefix option to all the requests that you make to the database. In this case, we have to use the triplex to prefix function because when you configure the triplex library, you have to provide a prefix for all of the tenants that it will be created. So when you create a tenant with name my tenant, in fact, what the name that triplex saves, like name of the schema, is the prefix you have provided, plus the name that you give it to your tenant. So we have to use this function to make it pass the correct prefix to Ecto library. And that's all that you have to do in your Phoenix application, because the rest of the process where the data is returned to the controller and then presented to as a response is the same for all of the tenants, because we are already sure that all our tenants have the same structure of the data. The only thing that changed is the content. In order to create migrations, you have to use also the triplex library in order to apply all of the migrations that you have created to all of your tenants, because it's very important to keep the same structure for all of them. So the triplex library provides a mixed task for creating migrations and for applying them for all of the tenants. The difference with the Ecto migrations is that the tenant migrations are saved in another directory. So when we call triplex migrate task, it looks in this special directory and applies all of the pending migrations to all of the tenants that we have, that we already have in our database. If you are used to use the generators that creates Ecto migrations for you when you create a new schema or a new module, you can use them, but then you have to copy the generated migration into this special directory in order for it to be applied to all of the tenants. So the structure of the migration is the same, only the place where it is saved is different. Also, you have to take into account that when a new tenant is created, all of the migrations that you have in this repo tenant migrations directory are applied to this new tenant. So take you into account when you are creating migrations. So you cannot create migrations based on the data, for example. So there is, you have to pay a little bit more attention when you're creating migrations if your application is multi-tenant. So just to summarize, the benefits of this approach is that you have the data of each tenant isolated from one another. So if you don't have to mix the data never, it's very usual to have it isolated because it's very easy to remove a tenant, to add a new one, and also to replicate one tenant because it's just a dump restore of the database. You don't have to make anything special to extract the data of one tenant from the rest. Also, it's one of the benefits is that you can use one instance of the applications to serve all of the tenants. If you, for example, add a special configuration table in all of the schemas, you can provide a little bit of configuration for each tenant and even use it, for example, to have different layout for each one or for do some special, for example, let each tenant have its own logo. These small changes that will differentiate the different tenants can be included also in this model. What is not so easy to do is mix data from different tenants. So if you know that, for example, if you are developing an e-commerce application and every shop will have its own site, you can use multi-tenancy because when the user goes, it will go to the site of this shop and buy products of this shop. But if you want to make a marketplace where one user can buy products from different shops, this is not a good fit for you because in order to take the data of the different shops, you have to traverse different tenants. You can do it if you need it, but if this is the main feature of your application, then the multi-tenancy is not a good choice for it. And also, Ecto is prepared to use a single push to connect to the database, so it can be, it's like more efficient. Inconveniences, well, you have to have a little bit of caution when you prepare your database. And when you make migrations, you have to take into account that everything is always applied to all of the tenants. So if you forget to apply some migration to some tenant, it will break. So it requires some more, it's a little bit more expensive to set up, but that is why you have libraries that assure that all of the changes that you make are applied. As I already thought, it's very important to use it only when the data is totally independent. And that's it. It's not difficult, it's special, so use it only if you need it, and you already have everything that you need in order to use it in your Phoenix applications. Thank you.
Thank you, Veli. Are there any questions? One here.
Great talk. Thank you so much. Did you ever run into, or already run into, any kind of limitations with Triplex? For example, I'm using it, but I only have like 40 tenants right now. And I notice already the migrations, they take a while, you know, and they always need to pay attention. Oh no, that's not my normal migrations, that's tenant migrations. I make the mistake every time. But what happens if you have like thousands of tenants, you know? Does anybody ever explore something like that? Does it take like 45 minutes to run those, or I don't know?
No, I don't know. In our project, we have like 30 tenants, so it's very good fit. Yeah, but it's I can live with it. Yes, I don't know if you have a lot of tenants. Yes, the migrations can take a lot of time, and you have to take it into account. Yes.
Cool, thank you. Any more questions? Yep.
So, thank you for the talk. You said that the data between the tenants cannot be shared in any way. But if you have common tables, maybe in another schema, can you just join queries with other schemas? Like, I don't know if, for example, in Postgres, is that possible?
You can access the data in different schemas, but I don't think that you can, you have to take the data from one schema, then the data from the other schema, and then you can mix them.
Okay, but not in a single query.
I don't know, I'm not sure
okay,
if you can do it. But if you have, for example, some lists that will be common for all of the tenants, you can put them in the public schema, and then you take this information from the public schema and the rest of the information from the rest of the schemas.
Okay, thanks a lot.
Thank you. Any more? Yeah, if not, I have a question of my own. So I think you've alluded to the answer in your talk already, but I was thinking about the advantages of this versus having, let's say, a client's table where you filter by client ID. That way, the data isn't isolated. So one of the advantages is the data isolation, as you said. Can you explore further advantages of using multi-tenancy versus just getting data based on where clauses?
Mm-hmm. One of the benefits for me personally was that in our project we have to replicate a lot of the data, because it was like annual information that our clients put there, and then they said, no, but the next year I will do more or less the same, so I want to copy all the information from this year to the next year, and then I will change what I need. So with this approach, it was just a dump restore of the database. But if I have used the other approach, using tenant ID in different tables, I had to prepare mixed tags to extract this data, and then another one to put it again in the correct places. So I think that this is what made me think about the multi-tenancy.
Cool, cool. Yeah, thank you. So yeah, let's give a big round of applause to Ellie.